Bismillahirrahmanirrahim. Assalamu alaikum. This is the course of Introductory Mechanics, and today is lecture 7, and the topic of the lecture is dot and cross product of vectors. My name is Abdul Saboor, and I am working as lecturer at Department of Physics, Hot University and Science and Technology. The contents of the lecture are: first of all, we will try to discuss what is dot product of vectors, cross product of vectors, then dot and cross product of vectors in terms of unit vectors, and we will discuss the different properties of dot and cross product. Now, according to the definition of dot product, the dot product or the scalar product of two vectors is such that the result will be always a scalar quantity. So what is meant by this? If you have two vectors A and B, and if you multiply them and the resultant is a scalar quantity, which means it has only magnitude and no direction, such product is always called dot product or scalar product. Now if you consider the figure in which you have two vectors A and B, and there is an angle theta, and theta is considered to be less than or equal to 0, less than or equal to 90, and greater than or equal to 0. If you represent the dot product like as it has been shown in the slide, and mathematically it will be always equal to A dot B is equal to AB cos of theta, where B cos of theta is the x component of B vector, or you can say it is the projection of B vector along A vector. Now if you consider this figure, and since we know that A dot B is equal to AB cos of theta, and if you want to multiply two vectors having their component along the Cartesian coordinate system, that is an A vector which is equal to AXI plus AYJ plus AZK, where I, J and K are unit vectors. Similarly, B vector is BXI plus BYJ plus BZK, and if you want to take the dot product of these two vectors, so what would be the result? So if you take the dot product, you will get the A dot B is equal to AX plus AX into BX plus AY into BY plus AZ into BZ. Now, how did we get this result? If you consider the following considerations, means if you take the dot product between I unit vector and J unit vector, or J unit vector with K unit vector, and similarly K unit vector with I unit vector, be always equal to 0. Now since the angle between I unit vector and J unit vector is always 90, so if you take the dot product between them, so the cos of 90 would be always equal to 0, and the dot product between I and J and K, or K and I unit vectors will be always equal to 0. Similarly, if you take the dot product between the similar vectors, or the vectors which are parallel to each other, that is I unit vector with I unit vector, since the angle between them is 0, so cos of 0 would be equal to 1, and the dot product between I unit vector and I unit vector, or J into J or K into K unit vector, will be always equal to 1. So if you consider A dot B is equal, if you see that A dot B is always equal to AX into BX plus AY dy plus AZ into PZ, is simple mathematics in which you that I dot I is always equal to 1, and the dot product between the different unit vectors will be always equal to 0. Now the cross product. So what is meant by the cross product or vector product of vectors? The cross product of vectors is such that the result is always a vector quantity, which means if you take the product between the two vectors and the result is always a vector having magnitude in a certain direction. If you consider this figure in which you see two vectors A and B, having a certain angle between them, that is theta. And if you take the cross product between them, the resultant will be always perpendicular to vector A and B, or you can say to the plane in which you have vector A and vector B. Now, how to find out the direction of the resultant vector, or the resultant of the multiplication of two vectors, is by right hand rule. As you can see in this, if you place your index finger in the direction of one vector and your middle finger in the direction of the second vector, such that the angle is between them is 90 and or less than 90, so the angle also the final product will be always perpendicular, and the direction of that resultant vector will be shown by the thumb of your right hand. Now, if you have two vectors A and B, and which are shown in this figure, having an angle theta, which the theta is greater than or equal to 0 or less than or equal to 90 degree. When you take the cross product, that is A cross B, then A cross B can be written as AB sine theta into n unit vector, and which can be replaced by C vector, where C is a vector which is perpendicular to the direction of both A vector and B vector, or you can say the plane in which you have A vector and B vector. The final vector will be always perpendicular to the plane of the vectors which are contained in that plane. Now, whereas B sine theta is a vertical component or y component of the vector B. Now, if you have two vectors that are A and B, and they have their components along x, y and z directions, that is A vector having three components along x, y and z. Similarly, you have B vector which have three components along x, y and z. Now, if you take the cross product between these two vectors, which can be explained or can be mathematically done as, if you take the matrix and in which you have I, j and k in the first row, and in the second row you have ax, ay and az, and in third row you have bx, by and bz. And if you multiply them, so since we know that a cross b is equal to ab sine of theta, and which will be, and the resultant will be always perpendicular to the multiplication or to both vector a and b. Since theta is equal to 0, and between the two vectors having same direction, and that is I unit vector and I unit vector, and theta is equal to 90 for I and j, or with the k unit vector. So if you want to multiply, you will see that if you multiply them and their unit vectors will result in a way that the cross product between I and j and k will be always equal to 0. Since the angle between I and I is equal to 0, so sine of 0 is equal to 0. Now, if you take the cross product between I and j, and so the resultant or the result will be always k unit vector, which means that the angle between I and j is 90 degree angle between them, and so if you take the sine 90, you will get 1. And if you want to find out the direction, so if you want to find out the direction, you will get the k unit vector, which is perpendicular to both I and j. If you interchange the position between them, for example, if you in the product, if the j unit vector is first and the I unit vector is second, so it will change the direction of the resultant vector such that it is now in the negative, and it can be easily explained by the right hand rule. Similarly, for other unit vectors, you can also measure their final resultant vectors. Now, there are some properties of cross product and dot product. So they are for dot product, we have it obeys basically commutative law, which means A dot B is equal to B dot A. Means if you rotate or interchange the position of these two vectors, the final product will be always the same. It also follows the distributive law, which means A dot B into B plus C is equal to A dot B plus A dot C. Similarly, it also follows the dot product also follows associative law, which means M into A dot B if you is equal to M into A dot B, or it is equal to A M into multiplied by B. So if you change where M is basically a number, and you can change the position of this number. If you can first multiply with A vector, or if you multiply with the B vector, the product will be always the same. In cross product, it only follows distributive law and associative law, whereas commutative law does not hold for the cross product. And why the commutative law does not hold for the cross product is basically due to the direction of the final resultant vector. If you can see in the figure, you have two vectors A and B, and when you take the cross product between them, that is, your index finger shows the direction of A vector and your middle finger shows the direction of B vector, and the thumb will show the positive A cross B direction. If you interchange the position between them, means in multiplication, the B vector is first and the A vector is second, so the index finger will show the B vector and your middle finger will show the direction of A vector, and the resultant will be opposite to the first one, and it is in opposite direction. So A cross B is equal to minus B cross A, means the direction is opposite. So you cannot say, or you can say that it does not follow the commutative law of cross product. So this is the end of the lecture, and if you have any questions, please do contact me, and hopefully some different topic we will discuss in the next lecture. Thank you so much, and Allah Hafiz.